Alright, so we're going to finish off the getting ready section of this credit with rational and radical exponents with a review of how we write the ninth root of a to the third using a rational exponent. So the way we'll do this is I'm going to write this out. You will note that I can write this using a fractional exponent where the number that is outside the radical will go here and the exponent outside, or inside I should say, inside the radical will go there. So essentially the 9 would go in the numerator or denominator. And the 3 will go in the numerator's place. Now as you can see here, 3/9, though 9 can't go into 3 evenly, we can reduce 3/9 so that it's, so let's go ahead and reduce 3/9. I could write this out as 1 times 3 and 3 times 3. As I can see, the 3's cancel out and I'm left with 1 over 3. So that's a to the 1/3 power. If it had been able to divide evenly, so let's say for example I'm going to make up some numbers that my exponent was really 10 over 2 or 10 divided by 2. Since that is divisible, I could write this as a to the 5th. So just so you know, you can have an example of when it does divide out evenly and when it does not. You always want to reduce. If you can't divide evenly, just make sure to reduce. Alright, go ahead and try that out for number 7, 8, and 9. And what we're going to do next is actually start 10.1, inverses of simple quadratic and cubic functions, by looking at an example from your textbook. So I'm going to pull 2 examples from your textbook and have you try out the problem in your packet. So you can see here from our textbook we have example 1. It says take our equation here, restrict the domain of each quadratic function. So that's the first thing we have to do. The next thing we have to do is find its inverse. Okay. The next thing they want us to do is to confirm the inverse relationship, and then last but not least, graph that function. So we're going to restrict the domain. The first thing you'll notice that we're going to do pretty much for every single problem is we're going to restrict the domain. Remember, domain is just all the x values. So when we have a graph, we usually have on our x-axis positive numbers and negative numbers, right? So when we restrict that domain, what we're saying is we want just the positive x values. Now that makes sense because, you know, we will learn that essentially a lot of real-world situations deal with just positive values. Now this is a less fancy way of saying we're restricting the domain to positive x values only. This is a more fancy way of saying it where all my x terms that are greater than or equal to 0. And that makes sense because all positive numbers are greater than or equal to 0. Alright, so that's the first thing we've done. That's number 1. The second thing is to find its inverse. So I'm going to take my f of x equals 0.5x squared. What I'm going to do is I'm going to replace, just like it says here, replace f of x with y. Okay, will do. And it states, so I did that. I'm finding the inverse right now. So I can write 0.5 actually as a fraction. That's like half a dollar. Like half. Not like half, it actually is half. The next thing we're going to do, just it says here, multiply both sides by 2. which coincidentally is the reciprocal of 1 over 2. So reciprocal of 1 over 2 is 2 over 1, or 2. So I'm going to multiply both sides by 2. That cancels out. I'm left with x to the second power equals 2y. Alright, cool. The next thing I'm going to do is, it says use the definition of the positive square root. So essentially, the opposite of squaring something, just in case you forgot, is square rooting. And what that looks like visually, essentially, let's say I have something squared, I can square root. Alright, so that would be x equals, so essentially that would be x equals square root of 2y. Alright, the last thing we're going to do for step 2 is to replace, to actually switch the x and y value. So instead of x going here and y going there, much like we did in our warm-up, right? I'm going to switch places here. And just like it says here, replace y with f inverse x. So instead of that y, I'm going to switch it with f inverse x square root of 2x. Alright. The next thing we're going to do is, it says to confirm the inverse relationship using composition, which you can do. You can also graph this out using Desmos. I'll show you how that shows if it's inverse. So in your textbook they do go over how to kind of find this algebraically. So we're going to go over how we can confirm the inverse relationship as well as graphing both of these functions. So I wrote both of these on the same page so you can kind of see, and it says to restrict the domain, which we did. We're only including the positives, and reflecting the graph over y equals x. So just so you know, y equals x is just a line that goes from corner to corner, and I drew a dotted line here. We're going to see how these two graphs kind of reflect over that line and are in fact inverses using something called Desmos.com. This is going to be a very interesting and very useful tool to use. So I'm going to minimize this screen. We are going to keep that, and I'm going to open up Desmos. It's already there, and this is the page that it'll bring me to. So I'll go ahead and start graphing. What I will do is, here our two equations are f of x equals 0.5x squared, and f inverse x is square root of 2x. So what I'm going to do to create a table of values, so that way I can graph these on my own piece of paper, I can go ahead and press the adding symbol, go to table. I'm going to erase that little 1 for the x and the little y there. I'm going to write in my first equation, which is 0.5 x to the second power, which I like this little keyboard. You can hide it or you can show it. It's up to you. And I will put in also our other equation, which is square root 2x. Alright, and as you can see, there's nothing there, right? Since we restricted the domain to be positive numbers or 0, I'm going to start with 0, 1, 2. What's awesome is as I kind of put in more and more numbers, 0, 1, 2, 3, 4, you can start to kind of already see a pattern emerging. Now I know that's not quite clear because you know, there's no smooth line, it's just a bunch of dots, so I am going to write down in my next value here the two equations. So instead of writing f of x, I will write y, because Desmos does understand when it's y. Y equals 0.5 x to the second power, and y equals the square root of 2x. Oh, and since we're restricting, I'm going to kind of just maybe zoom in. Ooh, that's a nice function as well, to zooming in, zooming out. So we can see that, oh, they do actually kind of mirror each other over our equation y equals x. They do actually. Let me minimize that keyboard. Again, you can show it or hide it. And you'll see here that, oh, it does show that not only do I have a graph that I can now write on my own piece of paper, because I do have a table of values, but I also see that they are, in fact, inverses, because it's kind of like they are opposites or reflections of each other. So without doing any of that confirming by composition, we visually were able to see that they are, in fact, inverses of each other. And we can use this tool to help us with the next explain and the problem in your packet.